Gadget UK back here again. This is a follow-on video to the PC Engine video I did recently. There were 4 or 5 things I looked at when I did that video. So I mean, first of all was this pickup, and then I cleaned them up. Primarily, vanish. I needed a tiny bit of H2O2 there on the underside of the controller. But yeah, and then the other thing was obviously this spares unit I looked at. And I did a composite conversion here. Now I revisited this the same night, actually, same evening that video went out, because after having done that mod, one of the things I thought about is I shouldn't really be connected directly to the left-right audio and the composite video, because there's a risk there from static discharge. Depending on the chip, sometimes there's some level of protection, ESD protection in there with some Scotty diodes or something similar, to act as a clamp. But I can't find any data sheets or anything for those chips, so it's anybody's guess as to whether they're protected. They probably aren't. And in fact, one of my subscribers posted a comment on there on my video as well, previous video, suggesting the same thing, that you do need some protection or something, so some amplification, because the audio is quite quiet. Now at the time I didn't notice that, actually. The audio was pretty good, but then switching TV over to one of my other consoles, like my Mega Drive or something, suddenly the volume was like twice as loud as it should be. So that was an indication that evening that I needed to do something. So now I'd already ordered some little PCBs I'll show you in a minute. It's like an audio amplifier circuit. It's designed for the MVS, actually, but I've used it with other things in the past and it works really well. So I've used one of those. I'll show you the PCB after, and I'll tear this down and just show you, assembled inside there. And I also put a cap in line with the, electrolytic in line with the composite. It perhaps needs, like I say, a diode clamp or something on there as well. But for the moment I've just left it like that, so I've got a amplifying the audio that makes the volume louder, but also that's isolating the audio pins which come out of the CPU, incidentally. I think I could be wrong. So you've not got a direct connection there, and obviously, like I said, the composite's got the cap, which primarily is there to help filter any DC from getting backfed into the the composite output. But the other thing now I wanted to show you here, this is really important actually. You'll see that I've got a different power supply here. I bought a dedicated 9 volts 1.5 amp power supply, and there's some reasoning behind this. It wasn't just a case I wanted a dedicated power supply, it's the voltage. If you remember when I was testing this other unit, the heatsink there gets extremely hot, which is no surprise, because you've got a load of voltage there that's been converted, into heat, and the higher voltage you put into this, into the input side of this 7805, the hotter it's going to get. And that heatsink, as I've previously shown there, is very, very, very small. So I think on a Mega Drive power supply, it says something like 9 volts on it, but actually it outputs like 13 volts or something daft. So you get a lot of extra heat generated, and just after maybe a minute or 2 minutes of this being on, it's pretty damn hot actually. And on this one you could feel it, after about 20 minutes you could feel this area here is pretty hot, pretty warm, and that's not normal. I don't think that's right. So like I said, going to a dedicated 9 volt power supply, it's probably 15 degrees less, maybe even more than that, I don't know. So I'm going to do some temperature checks on that. I'm going to get the Mega Drive power supply connected to this unit. I'll show you what's going on with the temperature there, and then we'll use the other power supply, leave it on for 10 minutes again, same sort of amount of time to warm up, and we'll measure the difference. So the other thing here, this is like I say, an update also on this one. I'm sure this cable's going to come off here, it's been wobbled around that much. Might need to strip off the ends and resolder it back on at some point. But anyway, yeah, this is the progress on this board. You'll see that I swapped out the chip there. I think that's a Fujitsu or something, I think it is. It's got an F on it. Yeah, it probably is. So I got, I think that's an M8864. It didn't solve the problem. I was a bit sceptical because there were a few things running through my mind after I did that video. And I was looking at the scope measurements I was getting there, and it was on the second data bit. I think bit 0 was okay, bit 1 seemed to be pulled low, but then when you switched it off and on, it jumped up and went back down again. There's probably a logical reason for that, and it's probably that that bit was not outputting anything. So I mean, if the CPU is running through some code, or it's reading something from here, and all it's getting back each time, it's bit 0 is low, that's what you're going to get. It looked strange. My scope always gives strange signals. I'm sure that scope is not, something's not quite right with it. But for the most part, you can use it okay for diagnosing certain types of faults and things. Certainly, I get a nice clean square wave if I stick it on the calibration outputs. So I do think, it's probably the strange signal, probably the length of these wires as well. That's probably going to be adding to the strange data line levels, signals that I was getting there. But in terms of the level, I think it was just bit 1 was outputting a low, and it was just looping around in a very short loop or something there, just trying to read that one address or something. So so I swapped that out, no difference. I then swapped out the VRAM. You can see there's a Sony chip there, that wasn't there originally, and that's another alternative manufacturer I had a new spare of. Both of these are like 62256 equivalents, and I think those are okay. I did check the data sheets and the pinouts seem to match. The speeds these are faster, so it should be alright, but that didn't make a difference. And then finally I've reflowed, you might be able to tell there, I don't know, I've reflowed all 3 of these quad flat packs, and just for good measure I checked all of these caps as well with my ESR meter. You see this blue one here, that's one that's been swapped out. What's strange is, my good ESR meter, I've lent it out actually at the moment, so I'm using one of those cheap ones from China, and all the other caps measured okay, aside from the fact that they don't give you the right microfarad rating, but when I remeasured them in my proper capacitance meter that I trust, the capacitance is right. All the 1 microfarads are 1 microfarad, and they seem good. But the ESR side, I checked. In particular, all of the 1 microfarads here, there's quite a block, there's about 8 or I think there's 8 of them, 8 1 microfarad caps in various positions on here. And this one that was down here, which is right next to the heatsink, was measuring it as leaky. And I tested it probably a good 20 times, and every time it said it was leaky, and the others were all fine. So I've swapped out that cap. So whether that cap's had anything to do with the failure here, I don't know. But coming back to the heat thing, like I say, this was the only chip that got just slightly warm. But it's no surprise, this heatsink, like I say, starts to dissipate an awful lot of heat, certainly with a Mega Drive power supply. So I can't help but wonder if that's what's happened in the past, that it's a heat thing. Heat is going to spread into the local vicinity there. This is the first thing in line, really. It's like I say, it's one of the first things that warms up. Maybe that's a clue that is faulty. And that's the 6260. I think that's the GPU. I think you've got the CPU down here is at 6270. And the 6280 is I/O sound, I think. I could have those the wrong way around. I've got some diagrams I'll show you in a minute, actually, the pinouts of these chips. But in the meantime, I forget his name, I'll post his name up here. Thanks to him, I've managed to source some spares, both the 6270 and the 6260. And they worked out about $15 each, which is remarkable, really. So that will be here in a few weeks, so that's going to be another follow-on. But I think it's the GPU. I think it's the GPU. I think that's where the fault is. And I'll show you something interesting now, some interesting progress I've just made. So I've got it all plugged in, switch it on, there's no cart in there, just to show you, we're getting a white screen. So that's the first oddity that shows something's not quite right. Now if I switch it off, I'll point you back at the system again. And we've got a few different carts here, a few different hue carts, and I'll show you. We've got Operation Wolf. So it goes black, then white, just as it did previously. I'll show you. So it's like there's a reset happening there, and in fact you can induce that reset, and I'll just show you that actually. How you do it. The top 2 pins on this chip here are the reset and the clock. So if you just very, very briefly just short the clock to the reset line, it will reset, and you can see that happens. So the reset's occurring. That's something useful, I guess. You can test that there, like say on that top left hand pin of the 6270. but it does nothing. You know, you don't get any activity, and it's the same with all these games. I've got a few different games here, except for, and this is the interesting thing, Space Harrier, and this is, you know, it's just something to learn from, really. That bear in mind, and it doesn't always make a very good connection, that game. Sometimes I have to put it in and out a few times. That's it. Yeah, I don't know why, it's not a very good fit, but as you can see, we've got a black screen, but we've got the title music up. Now, this was a big clue to me a few days ago. This is what made me think that actually it's just the GPU, because if the CPU wasn't running, I don't think this wouldn't be happening. You wouldn't get music, and obviously if the sound chip was majorly fucked, you wouldn't get the music either. So I think, I'm speculating here, if I was to look at the what was going on with the logic analyzer there, I would suspect that it's looping around, CPU's looping around, waiting for some sort of normally expected response from the GPU, like I don't know, V blank or H blank or something at a certain register being updated to say that an initialization's happened, or sprite hits or something. I don't know. That's what I think. But it's interesting. Let's say switch it off and on, and you get the music, and it's perfect. There's no issues there. So I think that's evidence that there's something not right with the GPU. There could be something wrong with the CPU, but and there could even be something wrong with the the I/O stuff and the sound chip. But I think it's more probable it's the GPU. There's certainly no activity on the GPU data bus. I'm not sure if I showed it previously, but like I say, I've measured the data and address bus here. The address bus has got some activity. The data bus is just nothing. It's just nothing at all. And in fact, the address bus has not got much activity on it. So I don't know. I think the GPU. But I mean, I've got a CPU and a GPU coming, so we can always try each chip. You know, I'll try the GPU first because that's my first thought, and then we can try the CPU. So it's been on about 5 minutes here now using the new power supply, and as you can see, it's around the 27, 28, 29 degrees mark. 30, there we go, 30 degrees. And it's barely lukewarm. It is a warm day in here. So the Mega Drive power supply has only been on for a minute here, and I don't know if you can see this, I'm getting 37, 38, I had 39 a minute ago. There you go, 37, 38. And it's literally been, it's going up, look, 37.8, 0.1, 0.2, 0.3. It's going up, and it's red hot, you know, compared to the other power supply. And it is working, I'll show you. You can hear it. But it's noticeably hotter. Yeah, 39 degrees I just measured there then. And it's only been on a minute. Like I say, that other one was on 5 minutes and it was just barely 30 degrees. So yeah, your power supply is very important on these PC engines. You want something that is outputting around 9 volts, because that 5 volt regulator only needs, I think, a minimum of something like 8 volts to run. So there you go, here's a quick look at the insides of this now. You can see I've got a cap there to the composite on the connector, and we've got a little PCB here, supported by one of those little clamp things I've got. You probably saw that on the ZX81 when I did that mod. It just holds it up. There's plenty of clearance there, so it won't interfere with anything on the board there. I could always put some insulation tape or something over these, but that is not going to move. That's not going to move at all. But it is just the MVS amplifier board. I'll show you one of those bare boards in a minute, so you can see how simple they are, really. Yeah, the hardest part is actually putting this damn thing back together, trying to get the board in the right place and then the LED lined up in the right place in there, as you can see. But there's enough room in there now for the RGB amp when that comes. But right now, I'll want to reassemble this. I'm going to show you that I think this unit is actually working, the backup unit. So the interesting thing with the backup unit here, you'll see I've got some batteries in here now. Previously, when I powered this up with, how's it gone? Populous in. Now, bear in mind, Populous has got RAM in there. It's a ROM RAM card. It's I think it's the only one actually in the collection of PC Engine games that were released that has its own backup RAM on board, save RAM. You know, so if I switch that on now, point at the screen, you'll see the main title just comes up straight away without issue. Now, if you've not got batteries in here, you get an error message. In fact, I'll show you that now. So I've took my batteries out, switch it back on. Hopefully it will have lost its charge. There you go. Interesting thing, see that? Backup RAM. Now, I can't read Japanese, so I've got no idea what that means. I'm guessing it probably needs initialised, it probably needs formatting, it's probably like format yes or no, or, you know, something along those lines. And that, I'll show you it's consistent. If I switch it off and on, that will continue to happen. Unless I put the batteries in, but you'll still get the error when the batteries are there, but once you've chosen, I think, the first option that's selected there, which I think means format, it's then okay. So I think there's a good chance the backup RAM on this actually works. But what is interesting, and I can't find the answer to, is how this game you would utilise the backup RAM that's, you know, in the Tenakoi 2 here, rather than on the cart itself. Is it a case of it supports both? Does it write to both at the same time? I honestly don't know. I just find it curious that this game seems to have been designed to pick up that adapter on the back, despite there being backup RAM on the cart itself. So, I mean, does it override it? Is that what it is? Is the RAM on the car, on the Tenakoi 2, overriding the RAM on the car? I'm not sure. But as you can see, yeah, it's consistent every single time. I'll put the batteries in, and I'll show you the same thing when it's got batteries in. Hang on. Right, let's put the battery flat back on. There we go. Right, both batteries in. Switch it on. Oh, hang on. Put my controller in first. Right, switch it on. So we'll get the same error message, hopefully, and we'll choose that option, whatever that is. See here, backup RAM formats. Sorry, my cat's nudging the camera here. So we'll choose yes, and then that, whatever that is. So the game's there. Switch it off and on, and hopefully it should just skip that error now because it's formatted it. There you go. Now the interesting thing is I got to the second round on this yesterday, so let's choose Conquest. Let's just see if we're going to load. I don't think it defaults, it goes to Genesis, doesn't it, the first round. But if we hit the start button, try to load a map, load a game, let's see what's there. I think I just pressed the wrong button actually. Genesis. So it has lost the settings. For me removing the battery, it's lost the settings. So I would suspect that the backup RAM on the Tenakoi 2 here is overriding the RAM on the car. And if I saved the game without the Tenakoi 2 on the back, I suspect it would save to the car, I think. But anyway, please post in the comments below if you know more about how that works. I did try to find a manual for this game, but I'm not sure if it was a US release. It may well have been. If you've got a US manual, please let me know what it says about the backup RAM and how it can be utilised, and what happens if you've got additional backup RAM in the form of a Tenakoi 2, or if you put this in like a Duo or something that's got backup RAM. So just a quick look at the PCB here. You can see the one that I used. This is designed for the Neo Geo MVS. You can get this. Oh God, what's the name of the website? I can't remember. I'll put it up here. And I'll put some links down below as well, just in case you want to just click on the link and go directly to the website. But you can order these, and they work out about, I don't know, $2 or $3 each or something. You get, I think, 3 as a minimum order. It's like $8 or $9, I think, for 3, which is pretty good, really. And it's an open source, you know, design that someone shared there on their website, so that's really cool. You can see, you know, the connections in here. As this is designed for the MVS, there's 3 audio pins there. I think it says AUD, and then you've got 1. In fact, this is 132 there. You probably won't be able to see it, it's not going to focus very well. But you've got 3, yeah, the centre pin is the centre channel. And you've got 4 caps here. And the centre channel goes through these 2 caps and through the 2 resistors. So what I did is, because this has only got 2 audio channels, I didn't mount the 2 capacitors there in the middle, and I didn't mount those 2 resistors. So the centre connection is not going to do anything. It's not going to pass through and merge with each of the other channels, the left and right channels. So in theory, you just have a cap on each side. The middle 2 positions are empty, and you have a 1K resistor on each side there of those 4, and the middle 2 are missing. And then you just populate the rest of the board there. So, it takes a couple of these 2SC 1815 transistors, one on either side, a couple of 4.7 microfarad caps, some 10K resistors, 680 ohm resistors, 120K resistors, a couple of 4K7s, I think, and 2 10 microfarad caps there on the output, 2 10K resistors as well that feed through to the output. And then this is designed, I think this connections up here are designed for like a DIN or something for the AES, you know, or the MVS rather. And you can see it's got like a sync +5 and ground. Well, a sync on the RGB connection. So if you're not going to be, you know, in my case, I'm not using the RGB stuff there. So I've not, you know, all I've done is just literally use my left and right wires going into the sound part here, and ground and +5, which for the amp, you know. And that's it really. You know, your outputs, you can tap them off here. I forget which pins it is. It's something like that one and that one, I think, or something. I don't know. You need to test continuity to the two caps there, because they're the final component on the output stage. I think if you test the negative, the positive lead, or the negative, I can't remember which way around it is now. I think if you test the negative lead, you'll get continuity to a couple of those pads there, and that's it. So, and that's a really nice way of amplifying the audio and isolating and protecting the audio on the PC Engine here. There's probably other solutions out there, but this one, like I say, being open source, and I've used this before. I've used the same circuit here in the Atari ST for getting stereo, you know, amplified audio out of that as well, because this is better suited to the ST really, because it's got the centre channel of, well, you've got 3 channels, so yeah, it works really well in the ST. So something else I might end up doing as a follow-on to this as well is, now I've proven this is working, and we know it's got a 2K RAM chip approximately in that position there actually on the board. In theory, it's possible to stick a larger RAM chip on there, and it's also, in theory, possible to do some sort of mod to the way it's powered. You know, I'll deal with the power thing first. One of the things I thought is you could stick, you know, like a lithium ion rechargeable or something. You know, like one of the ones you put in a Sega CD or a Dreamcast. You could do a modification there, so that battery is powered by the, you know, the DC input. You need to be careful the way you wire it, but using a diode and stuff, you could do that. I'm pretty sure you could have a charge circuit there that you know, charges the battery whilst it's powered up, but then only, you know, it's connected to the SRAM. You don't want it powering anything else. You know, you'd have to isolate the VCC line to the SRAM on there. But yeah, that's one thing you could do. The other thing I thought about is swapping out the chip, as I say, for a larger chip. Now I've got some Dallas SRAM chips, the ones with a battery, you know, like a 10-year battery built in. Now it's a larger profile. It's like a standard dip, you know, the standard dip profile rather than the thin one that's on here now. So yeah, I need to perhaps produce an adapter or something. I could even just you know, mount one side, if we're showing the pin outs are the same, mount it on one side and then drill some holes through the PCB and then just attach wires underneath for the other side of the chip, and then have some sort of switching logic with an LED display or something, so that I can go through, you know, and some buttons, so I can go through banks, you know, up to, I don't know how many banks that would support. I think those chips are like I don't know, 128K or something, the ones I've got. I might have some 32K ones, but compared to the 2K that's on there, you know, that would give you quite a lot of banks of 2K, so that might be quite cool as well. I might do that. I'll certainly give it some thought. So just a quick update before I go now. As you saw before, I took the batteries out of this, and then it obviously wanted me to format the save RAM. I then loaded the game again, and I was surprised to find that my saves had gone. So, and then, you know, I've done a bit more research, because I was under the assumption from what I'd read, in one or two places, that the Populous version of Populous for PC Engine, because it's this ROM and RAM card, that it saves on this card. I don't think that's the case, because I've just read another article, someone who did a study and actually took the thing apart. It says there's no battery in there. It isn't battery backed. It's one of these things that they planned to put a battery in there, but it never happened, despite the fact it says ROM RAM card. And what actually happens is, you know, the save goes onto the NEC 2 here. So, and I know that's working because, let's say, my saves work. I've just played this again now for a good hour and a half actually this afternoon. Got up to the third island, you know, beaten the first 2 levels on this, got up to the third one, saved it, you know, powered it off, left it for 20 minutes, switched it back on, and the save is, you know, is present. But if I lose the batteries out of here, there will be no save, and we'll lose it. So that's interesting. Post some comments below if you can confirm, or, you know, if you disagree. But it would appear that there are no batteries. You know, there's no save support built into this. It really is a case of this card supports the save system if you've got the CD-ROM system with a battery backup in it, or the you know, in this case the NEC 2. You can also get a Tenecoe bank, I think, that's a card like this, and you plug this in, and it's 8K, and I don't know whether it boots a menu or something, allows you to copy the saves that are on here onto your Tenecoe bank card, so that you can then, it's portable, you can take it away from the system kind of thing. So I might get one of those at some point. It'd be nice if Crix could perhaps update the EverDrive, the Turbo EverDrive, to support that functionality. Not necessarily save functionality, because that's obviously handled by the the interface. You probably won't be able to do it from the card. But what you could do, I think, is support the Tenecoe bank card, so that it just writes it to a flat file on the SD card, because that would mean that you could use something like this or a CD-ROM system to save your games, but also then boot your Tenecoe on your EverDrive and save the files to your EverDrive and have backups of your files in a permanent sort of format. So that would be cool. I don't know how easy that would be for him to do that. In theory, I think it should be alright. You might need to add 2K of RAM to the cart, I don't know, but anyway, I thought you'd find those few things interesting. As soon as the spare chips arrive and the bits from the RGB mod, because I'm waiting for the PCB and some of the SMD components to do an RGB amp mod to this, and I'll do some comparisons there between Composite and RGB. And I've also got a Turbo EverDrive coming probably sometime early June, I would think. So anyway, thanks for watching. I'll see you. I've also got a Turbo EverDrive coming probably early June as well, so I'll cover that when that arrives. Anyway, thanks for watching. I'll see you soon.